Hello, my name is Alfredo Armenta, and today we're going to be doing the fourth and final project for this class. So today we're going to be finding the measurement of distance using an ultrasonic sensor and an Arduino. The objective of this project is to measure the distance of an obstacle from a sensor, analyze that data, and then to make a decision based on the set parameters. So this ultrasonic sensor consists of 4 different pins. It consists of a voltage pin, which in this case we're going to be using a 5 volts. We're going to be using the trig pin, or the input pin. We have an echo pin, or the output pin, and we have a ground pin. We also have our transmitter and our receiver. This particular pin out system has a crystal oscillator of 4 megahertz. So how does an ultrasonic sensor work? So basically it consists of 2 parts, a transmitter and a receiver. The transmitter transmits a signal that then bounces off of an object and is received by the receiver. In order to find the distance between both objects and the ultrasonic sensor, we have to use this equation down below. In this case, our velocity is equal to 340 meters per second, and our time is dependent on our program. Now, the reason why we divide by 2 is because once the transmitter sends out a signal, it travels a certain distance, and then it bounces right back into the receiver, which in turn travels twice the distance. That's why we have to make sure we divide it by 2. And recording, okay. So the schematic of the circuit on the breadboard shown here is very similar to what I have made. Now I will be showing you how I set my breadboard up. I don't have access to these images, so all these pins are not correct. The way I connected mine is that for the sensor that we used, our trig pin is connected over to pin number 3 on this side. Our echo pin is connected to pin number 2. Our buzzer is connected to pin number 13. Our red LED is connected to pin number 12. Our yellow LED, I know it says blue right there, but in this case I used a yellow LED, is connected to the 11 pin, and the green LED is connected to the pin number 8. Now our grounds are similarly connected. The ground connecting the LEDs and the buzzer, on my case, is connected to the ground of the digital pins. So on this one right here, just like this. And for our 5 volt output, is connected to our input for the sensor. I have it connected just like this, as well as our ground. So here are the necessary components to complete this project. We are going to need an ultrasonic sensor or a distance sensor. We are also going to need a microcontroller. In this case, I'm using an Arduino Uno. And then we're going to use 3 LEDs. I am going to use a red LED, a yellow LED, and a green LED. We're also going to need a buzzer, and we're going to need a couple of jumper cables. I used about 1, 2, 3, 4, 5, 6, 7, 8, 9 jumper cables, so you are going to need quite a bit of those. And then you're going to need your USB serial cable, and finally your Arduino coding. Oh, and you can't forget a laptop to use that. So for this project, you're going to need a breadboard, 3 LEDs, preferably these colors. I used a red, a green and a yellow LED. If you notice in the video, I am pointing at one of the legs of each of the LEDs. This signifies that our longest leg is going to be our positive end. So we have to make sure we put them exactly this way. We are then going to grab our buzzard. If you notice, it has a longer side and a positive sign on it. Make sure that positive sign is connected to your positive terminal. We are then going to grab our ultrasound sensor, and we're going to connect it just like this. And it should look something like this. We are then going to use a couple of jumper cables for this part. I used this orange cable to connect to my buzzer, and then I'm going to grab my other orange cable and I'm going to connect it to my red LED. And then from here I'm going to grab my yellow cable and connect it to my yellow LED. And then I'm finally going to grab a green cable and connect it to my green LED. I am then going to grab a black cable and connect it to my negative terminal. I'm going to grab another black cable and connect it to my negative terminal on my ultrasonic sensor. If you can see on the pin, it says negative or ground. And then I'm going to grab a red cable as my positive terminal, and I'm going to connect it to my 5-volt input pin. I'm then going to grab this blue cable and connect it to my echo pin. After this, I'm going to grab another cable. I only have this other black cable, so I'm going to use this black cable, and I'm going to connect that to my trig pin. So once you're done connecting all of these cables, you're going to grab your Arduino and connect a cable to it, which is then going to connect it to your laptop. If you noticed, on your Arduino you have your digital inputs and your analog inputs, as well as your power inputs. I am then going to grab this orange cable, which goes from my buzzer, and I'm going to connect it to the port number 13. Then I'm going to grab this other orange cable and connect it to port number 12, which is for my red LED. Then I'm going to grab this yellow cable and I'm going to connect it to port number 11, which is for my yellow LED. And then I'm going to grab the green cable, which is going to go on port number 8, which is for my green LED. And then I'm going to grab one of the negative terminals and connect it to the negative digital terminal. Then I'm going to grab the other negative cable and connect it to the power ground, and then the red cable goes to my 5-volt output. Then I'm going to grab my blue cable, which is for my echo, and it's going to go over to port number 3 on my digital side. And then I'm going to grab my other black cable and connect it to port number 2, which is also on my digital side. And this is the part where I connect the Arduino to my laptop. As you can see, the lights turn on, which means that it's starting to work. Now you'll see me do a small demo, but eventually I'll do a further explanation of this. This is how the program flow diagram looks like. We first have to connect the PC and the Arduino with the serial cable. From there, our transmitter is going to send out a signal and it's going to start counting time. Once our receiver receives that signal, then it's going to stop counting the time, and then the sound travel time is going to be calculated in microseconds, and then from there we're going to get our distance, which is going to be calculated in centimeters. If our distance is less than or equal to 30 centimeters, then our green LED is going to be on. If not, we go to the next step. If our distance is less than or equal to 20 centimeters, then our blue LED will be on. In this case, we used a yellow LED, so instead of the blue LED, it should be a yellow LED. And if that is not the case, then it will move on. And if our distance is less than or equal to 10 centimeters, then our red LED will be on. If not, then we continue to the next sequence. If our distance is less than or equal to 5 centimeters, then our buzzer will turn on and it will cause a noise. Now, if our distance is above 100 centimeters, then of course it would be out of range. And it does this all at the same time, so it keeps going on and on and on until the user turns off the code. This is the code that we used on our Arduino system. So we go to the very top, we defined our pins. We have our trig pin, our echo pin, our LED 1, LED 2, LED 3, and our buzzer. This LED 1 is going to be our green LED. This middle LED is going to be our yellow LED. And this short, or LED number 3, is going to be our red LED. If we go further down, this void setup is just telling what our pins are going to be. And we tell it that our trig pin is going to be our output, our echo pin is going to be our input, and our outputs are going to be LED 1, 2, 3, and the buzz. Now if we go over to our loop, you can see that double the duration, double the distance in. We have our digital writing, which is our trig pin. We do add a 2 microsecond delay. And then we have our trig pin again for the high. And then we also add a 10 microsecond delay. And then we have our trig pin low once again. And in this case, it's going to be reading our speed and calculating the distance. So the speed is 340 centimeters per second. And we are also converting our centimeters, which is our distance, into inches. So 1 millimeter is equal to 0.393701 inches. Now, once we convert our distance from centimeters to inches, we can go ahead and tell it how to calculate the LEDs. So here we tell it that if our distance is less than or equal to 40, we're going to change it into 30 centimeters. We're going to keep this at 20 centimeters, this one at 10 centimeters, and this one at 5 centimeters. So here basically it's telling that if our distance is less than or equal to 30, our LED 1 is going to be on high or turned on. Now, if not, it will continue on to the next step. If our distance is less than or equal to 20 centimeters, then our second LED will be on. If not, then if our distance is less than or equal to 10, then our LED will be on, number 3, or in this case, our red LED. And if our distance is less than or equal to 5 centimeters, then our buzzer will be turned on. If not, then if our distance is greater than 30, then that is just going to be displaying out of range. And here we can also add some more comments into there, just so that it could look nicely once we run the program. So as you can see, the sensor isn't reading anything right now because my hand is not close to it. But if I bring my hand a little closer to it, you can see that it turns green. If it goes back and forth, it's because I might go out of range. So right here I'm out of range, but here I'm in range. Now if I move my hand closer, you can see how it turns yellow. So the yellow light turns on as well as the green one, and that's because our hand is closer. Now if I move even closer, once I meet that certain spot that we have in the code, it turns red. Now I can continue going forward, and at some point the buzzer will go off, as you can hear. Now if I put my hand back, you can see how it starts turning off the buzzer. Then if I move a little bit further back, the red light turns off, And as I move back even more, the yellow light turns off. And then if I move my hand away completely, the whole system is off. And this concludes my last and final project for the semester. Thank you.